Friends, very good morning to everyone. We were heating water for cooking purpose or for using for bathing purpose and so on and so forth. Since centuries, around a century back, water was heated in a tank and heating source was fire, and by burning the wood we used to create fire. Later on it was replaced by fossil fuel like kerosene. Later on, it was replaced by petroleum gas. Then, the heating source was changed to electrical method. In electrical method came boiler, where a coil is introduced, heating coil, and that gets heated and which heats in turn the water. The time taken for heating with the fire source or with the electrical source, the time has got drastically reduced. Later on came the modified version of boilers, that are geysers, where the say, boilers are connected to the overhead tank and the water flows through a shower. Now we are taking one step ahead of that. They are instant geysers. The normal geysers, if it take 15 minutes to 20 minutes to heat or half an hour, the instant geyser will take 5 minutes to heat the bucket of water. What is this instant geyser? What's this difference between the normal geyser and the instant geyser? In the normal geyser, or the boiler, we heat bulk of water. Whereas in the instant geyser, the water is made to flow slowly through a heated coil and continuously. And what happened in the process? Instead of heating in bulk, which takes more time, we are heating the same water in a slow stream, or in other words, slow stream of water is heated. Instantly, we get hot water, and rapidity has increased. Today's generation, the Z generation, needs everything instantly and rapidly. We don't have that much of time and patience to meet the needs of this generation Z. The chemical synthesis has also changed from tank technology to tube technology. Today's subject of discussion is continuous reactors or continuous flow reactors, where this technology as of heating the water instantly has been utilized for carrying out the chemical reactions. What is the beauty of these continuous flow reactors? These are safer systems which runs the chemical reactions in a reduced volume compared to the tank technology, where there is an efficient heat and mass transfer. The heating is very efficient and conversion of the reactants to product is much more efficient. Continuous flow reactor is a safe system running chemical reactions in reduced volume with an efficient and mass transfer. The temperature, pressure, and molar concentrations are the three factors, are the three processes which has been intensified in this continuous reactors. As the name indicates, in the continuous reactors, the material flows in a stream. Reactants are continuously fed into the reactor, and their continuously product is removed from the reactor. There is continuous outgoing, and it is a continuous process. It is different from batch process what we followed before. This is very efficient when compared to the batch process. Thus, it has been utilized in varieties of chemical and pharmaceutical industries for the synthesis of various chemical intermediates and active pharmaceutical ingredients. The reactors which we used before were called as batch reactors. Here we see it has a tank where we add the various raw materials, and this tank is having the reactants which are heated and also stirred, and this is efficiently it can do in a batch process. After completion of the reaction, we work up, isolate the product. This reactors essentially operates in a semi-batch mode, and the chemical first is charged, followed by the second, and the reaction process goes on slowly and steadily. Reactants are added, reacted, and isolated not in a continuous manner but in a discontinuous manner. There are its own benefits of these batch reactors. They are very versatile in nature. They are not only utilized to carry out the chemical reactions but also used for different unit operations like distillation process, crystallization process, and extraction process, and so on and so forth. As it is a very old system and is very established also. Thus, batch reactors are also versatile, and again they are established. They are very efficient in handling solid liquid system where slurries are stirred in an effective and efficient manner. And they are also efficient in handling the products with foul smell. Thus, it has its own advantages. Old is always gold. But we cannot stick to old. We are changing, and change is permanent. We have to change according to the need. As this is useful for slow reaction, it is effective and is also economical. The economy is not the only thing. Effective is not the only thing. Speed is also required in today's world. Thus, the continuous reactors came into existence. Here, in continuous reactors, it is represented in the figure. The A and B reactants or reagents are mixed, and these reactants which are mixed flow into the reactor, which is essentially in the form, not in the form of a tank but in the form of a pipe without baffles. Baffles means without any separators, or with separators, which can separate these reactants from the products, and they may be interconnected with each other at different stages. The reactants are added, reacted, isolated continuously. Whereas in batch reactors, they are added, reacted, and isolated, but discontinuously, discretely. That is the major difference between the continuous and the batch reactors. It is something like you are reading for the examination. Continuously, you read bit by bit over the whole year. That is continuous reactors. Read one day before the examination, omit everything at a time. That is batch reactors. Which is more efficient? Definitely, it's continuous reactors. You become more perfect. That's why continuous reactors is the order of the day. They have its own advantages compared to the batch reactors. They are concentration dependent. Rate of reaction depends upon the concentration of the reactants. Higher the concentration, higher the rate of the reaction. And these reactors has more or better effective in handling this higher concentration. It's because of the fact that they are having superior heat and mass transfer capacity. Means they can be heated more efficiently, and more efficiently the starting materials can be converted into the products compared to that of batch reactors. The continuous reactors, one of the types are the plug flow reactors. These plug flow reactors have the advantage of separation of the reactants from the products. That's why it gives a better ranges of concentration profile. As and when it moves from the starting to the ending, the starting material goes on converted into product, and the product which is formed is at the end, and the reactants are at the beginning. And the process, the product is removed from the another end, and reactants is added from the starting end. They are smaller in size when compared to that of batch reactors. Because they are smaller in size, there is smaller volume, and our volume efficiently spread over a large surface area. That's why it is having higher heat transfer can be achieved over here, and better mixing can also be achieved, which makes it more easy to operate and more faster to operate. Thus, the runtime of the reaction decreases. This has more flexibility. Thus, continuous reactors is the order of the day, not only for lab purpose but also for industrial production purpose, where there is minimum human interference, where there is a continuous process, never it is stopped in between, continuous and steady. Right. The continuous flow reactors instrumentation is like this. This has the pumps. A represents the pumps. These pumps are used to deliver the solvents and reagents of required quantities in a reproducible manner and in a precise manner. In between they have the loops. B represent the loops, and these loops are utilized to introduce small volumes of reactants or reagents or catalysts in the form of liquids. The pumps or varieties of pumps are used. The major types of pumps used are piston type of pumps, peristaltic pumps, or syringe type of pumps, or gear centrifugal pumps. The reactants or the reagents which are pumped into the system are mixing at the T-piece. T-piece is the primary mixing point where the reagents and the reactions which are coming in the stream are combined efficiently and effectively. And this combined and mixed reactants along with reagents are moved into the coil reactor. Coil reactors are essentially a tube reactor, and which can be also connected to the column reactor. This coil reactors or column reactors can be in line with each other, or a single type of reactors can be used, and this can be heated effectively and also cooled effectively. In these reactors, mixing can also occur efficiently. Electrochemical reactions can be carried out. These coils can be radiated with microwaves, ultrasound waves. Even the photochemical reactions can be carried out in these reactors. Then, once it enters, at the end, we collect the product. The entry of reactants and the exit of product occurs simultaneously and continuously. And whatever the product formed is removed continuously. To avoid the mixing of the product formed from the reactants, they are having BPRs, that is back pressure regulators. It controls the pressure system that the products do not move backwards. And in the downstream unit, there is inline quality control, analysis, and also workup operations are carried out where reactions are quenched and worked up and the product is removed. This is the instrumentation of continuous flow reactants in simplest manner. I will show the anatomy of this flow reactor. We can understand it better. The reagent A and reagent B are pumped through the pumps of different types, and they are mixed in the mixer. The different types of mixers are used, and then they are fed into the reactors. Varieties of reactors are utilized. Afterwards they are quenched, means the reaction is stopped, and the intermixing of this product and the reactants are stopped by pressure regulator. The continuous collection of the product and the continuous input of the reactants occurs in a continuous and uninterrupted manner. The first part is the mixing. The second part is the reactors where there is an heat and mass transfer occurs and in a safe manner. The last part is the beneficial reaction completion and the outcome or taking up of the product. Various types of mixing units are used. Mixing is the essential part before the reaction, especially in the bulk quantities. There are three types of mixing units utilized for this purpose. The first type is the T-shaped mixer. As the name indicates, it is having a T shape, that's why it is named as T-shaped mixer. Another type of mixing unit is split and recombine mixers, that is SAR mixer. Multilaminar mixers. These T-shaped mixers has a T junction, and that's why it is also called as T junction mixture. These mixers efficiently mixes two different liquid streams in a rapid manner. This T junction creates planar and swirling flow with folds, and this folds breaks into turbulence, which enhances the mixing process. These are the general type and widely used type of mixer in case of continuous flow reactors. Split and recombine mixers are a static type of mixers. This effectively mixes the fluid by splitting them into multiple streams. The initial fluid streams are divided into multiple small streams, and then the small streams are routed through the channels where the mixing occurs, and this mixed one are again combined back into single outlet from different placing which it comes out. It gets combined and it is mixed efficiently before it is fed into the reactor. The multilaminar mixers utilizes the principles of laminar flow where the fluid layers, they move parallel to each other. The one fluid layer is moving in a one channel, the another fluid layer is moving in another channel, and when they come parallel to each other, they mix with each other by the process of diffusion. Diffusion is a process where the things moves from the higher concentration to the lower concentration, or from higher temperature to the lower temperature, and so on and so forth, which promotes efficient mixing. Diffusion is the process which gives efficient mixing in case of multilaminar mixing units. They're effectively used in the organic synthesis of the chemical compounds, in the pharmaceutical production of APIs, and in the material science. They also find their use in bioreactors to improve mixing and nutrient delivery for enhancing the growth and productivity of the cell. Various reactors are used. The mixers are called as the heart of the continuous flow reaction system. Reactors are the brain of the continuous flow reactor system. Generally, three types of reactors are utilized. One is the chip reactor, the second is the coil reactor, the third is the packed bed reactor. The chip reactor works on the principle of flow injection analysis, where the reactants flow through the defined channel on a chip. And these chip reactors are constructed from glass, or it can be made from silicon carbide or polydimethyl siloxane. These chip reactors have best heat transfer and mixing properties. But this is mainly used for enzymatic reactions and organic reactions of small volumes, as it has a very low throughput. This utilization is for enzymatic reactions preferably. Can also be used for organic reactions too, for small volumes. The coil reactors has a coiled tube or tubing, or we can use a pipe reactor through which the reactants pass through. These coil reactors are constructed from PTFE or PFA or stainless steel, depending upon the type of chemical reactions we use. The polymers tubes are used when there is chemical resistance required. Chemical resistant and thermal resistance is required. When the chemicals are not hazardous, stainless steel reactors can be utilized. The inner diameter of this coil lies from 0.01 inch to 1 by 16 inch. Compared to these chip reactors, the coil reactors are more economical. As they are more economical, they are most wisely used in synthetic chemistry for carrying out various types of organic reactions and also for production of active pharmaceutical ingredients or pharmaceutical intermediates. Packed bed reactors, as we see here, it has a column in which it is packed with a material. These are also called as fixed bed reactors. There is a fixed bed of the solid material, which are also called as plug flow reactors. They have a relatively uniform flow pattern across the cross section of the reactor. The solid or liquid or solid or gas reaction can take place. There is a solid bed of catalyst or solid bed of one reactant and a liquid or gaseous reactant flow through the solid bed of reactant or the catalyst. And during this process, these reactors are heated externally or irradiated by microwave waves or ultrasound waves, or electrochemically they can be heated, or any varieties thing can be carried out. And this type of reactors are packed bed reactors. These are especially used for heterogeneous catalysis or for heterogeneous reactions, where we have solids as the one of the reactants or as one of the catalysts. They stimulates effective molarity of catalysts.